This video shows how ZOS REXX was used to solve the Advent of Code puzzle for Day 1, Part 1. The objective is to find the ELF that carries the most calories. Let's take a quick look at the input data. The data is stored in a PDF. This PDF is defined as Fitch block LRECL 80, and it has several members. We are interested in the member named Day 1. Records 1 through 14 are the items for ELF number 1. There is a blank line between the ELFs. Thus, ELF number 2 is on record 16, and that ELF carries a single item with over 30,000 calories. ELF 1 is carrying a bunch of candy bars, and ELF 2 has a cheesecake. Notice that the calories are different lengths. Most are 4 digits, whereas the calories for ELF number 2 is 5 digits. The calorie data for ELF 3 starts on record 18. Match to the bottom, and we see that there are 2,236 records in this member. The data for the last ELF starts on record 2,230. Notice there is not a blank line after this ELF. The code is going to need to account for that. This is Dinosaur Parkour, faster, better mainframe programming. Now that we have an idea of how the data is formatted, it's time to view the code. The answer to the puzzle is the amount of calories, so the logic needs to calculate the total number of calories for each ELF and figure out which ELF carries the most calories. Line 1 is a comment that contains the word REXX because this tells TSO that this is a REXX exec rather than a CLIST. Now this is going to be a batch REXX, but it still needs to be run under TSO. When we look at the JShell, it will be using a TSO utility to run this strip. The reason that this strip has to run in TSO is because of line 9. EXECIO is a TSO command. Line 18 uses an if statement to evaluate a string. REXX handles that, but line 9 is just a string and REXX is not told to do anything with it. Thus, REXX passes this line to the active environment, which is TSO, because line 8 sets it. EXECIO was code to read all of the records from a DD statement named input and store the data in a compound variable that starts with data. It was also told to close the file when it completes this request. Lines 11 through 14 initializes some variable. Lines 16 and 17 use the data compound variable that was created by the EXECIO on line 9. Many programmers refer to this as a stem variable. Stem variable and compound variables are synonyms. What EXECIO did was put the first record in data.1, the second record in data.2, and so forth until the last record is read, which is stored in data.2236. At this point, EXECIO created data.0 and stores the number of stem variables that were created in it. Line 16 is looping from 1 to 2,236 because that is what data.0 contains. Line 22 sums the calories on record 1 to 14 into a variable named total. Record 15, which is stored in the compound variable data.15, is a blank line which makes the condition on line 18 true. Line 19 calls a procedure named ELF break. ELF break is what many languages refer to as a method. ELF break displays how many calories the current ELF is carrying. If the current ELF is carrying more calories than a prior ELF, it saved the number of the current ELF and the calories being carried. Line 36 resets the total to 0. Line 37 increments the F count by 1. Control is returned to line 20, which tells REXX to start the next iteration of the loop on line 16. This is done to skip the blank line. Remember how the last F did not have a blank line following it? That is why another call to F break is required on line 24. This allows F break to check if the last F has the most calories. Line 25 displays which F is carrying the most calories and how much. This is the JCL to run the strip. IKJEFT1B is an entry point into the TSO environment utility. The parm equals is being used to name the REXX strip member, R01. The member R01 is found in the library named on the sysexec DD on line 5. Line 7 names the output DD. This is where the output from the say commands are shown. Line 8 is the input file. Remember that the EXECIO specified that it was reading from a DD named input? When this job is submitted, it is sent to JAS, the job entry subsystem, which runs it. The output for the completed job is found in the output queue. A question mark is used to expand the job by DD name. The letter S is used to select the terminal output DD, sys TSO print. We see how many calories the first 17 L's are carrying. M is entered on the command line and PF8 is pressed to match page down to the bottom of this DD. Now we see the last few L's and the answer line. F86 carries the most calories, 70,296. There are 2 parts for each advent of code puzzle. When part 1 is completed, part 2 becomes available. In part 2 of the puzzle, the elves are worried that the elf with the most calories might run out during the day. So they want to know the top 3 calorie carrying elves. The 2 variables to handle the finding of the elf with the most calories were replaced with compound variables. See line 13, 14, and line 26 to 30. The meat of the new logic is an elf break plus a new procedure. The if statement in elf break has been replaced with a case statement. Line 37 through 43 determine if the current elf needs to be in the top 3. If it does, the info for the current elf is added to stem 1, 2, or 3. The new procedure is add. On line 38, this procedure is invoked as a function. That means that the return on line 61 has to return something. It is returning a null string. If the current elf needs to be in the top 3, the loop on line 52 to 57 handles the shifting of the position. If the current elf needs to be in position 2, this loop moves the elf in stem 2 into stem 3. Line 59 and 60 places the info for the current elf in stem 2. When the strip is run, the top 3 elves are shown and the total number of calories that they carry. Thank you for watching. Let me know if you're interested in seeing more puzzles from the advent of code being solved on the mainframe. Oh.